now we can start.
Yes.
Uh, let's talk about first of all, I introduce myself. My name is Mukul, and I'm an embedded hardware engineer with experience of 5 years in new product development. And I have worked on schematic designing, PCB help in the PCB layout, hardware debugging, BOM creation, and the circuit designing for the EMI EMC testing and for product certification. We need various certification for the PCBs and the products. So I am working on that. I work. I worked on projects such as tracker systems, which is based on GPS, GSM, and MCU, and water level monitoring system, which we have to monitor the water in the tank, then store in server, then we can store the water level uh, from the app.
Mukul, can you speak some loud? Some echo
I,
sound.
Yes, Mukul. I think, yeah.
Give me a minute.
I think, Mukul, better you can use the headset. Yeah, it would be fine.
Now my voice is clear.
Yes, pretty
Yeah,
fine.
Mukul, perfect.
Then I worked on IPIS system for the Indian Railways. Then DMRC, some DMRC project for the CCTV. Now during this webinar, I'll show you the how electronic products are designed from an idea to a final working product. First of all, what is embedded system? Can you tell me? Anyone tell me? Why
Mukul, sorry for interrupting. Actually, still we are getting some echo from you. Yeah.
Hello. Now you are getting some echo.
Echo
also?
is there. Yeah. But and your voice also is less actually. So yeah.
Okay. He just.
Meantime, you guys, you can answer for the Mukul question like what is embedded system. Please make session interactive, okay? There's no one judge you like based on your answer, okay? Please try to interact. Anyone?
The hardware and software, the combination of hardware and software is known as embedded.
Okay. And Kumar texted like embedded is a combination of hardware and software. Okay. Any other answers? Yeah, Nilu, that is perfect. And Ankit, Kumar, yeah, fine. Any other answers? Mukul, is it all fixed now?
Now my voice is clear. Got better.
Yeah, clear. Okay, you can try to continue.
Yeah, still some echo is there, but try to speak louder. Yeah, Mukul. It will be yeah.
Okay, some of told na like hardware and software. What is the meaning of hardware? Anyone? Meantime, Mukul came in, then we can discuss something about what is hardware here. What is the meaning of hardware? Anyone? Hardware like PCB. Okay, great, Ankit. Any other answers?
Hardware, hardware like sensors uh, on PCB
Okay.
having electronics component, resistor, transistor, IC.
Okay. Yeah, Ujjwal, that is also perfect. Anyone? Any other answers?
So hardware means physical.
Like a physical
material.
component you are saying? Okay,
Yeah.
physical
Yeah,
material
right,
is
sir.
existed. Okay, fine. Components which can touch and feel. Yeah, this is perfect. Yeah, Kumar. Then what about software? Hardware, all the physical components of the device. Yeah, that is also fine.
So software just like a program, group of instructions,
Okay.
set of instructions.
Okay. Yeah, perfect, Neelu. And Ankit also told like software like program. Yeah, coding. Okay. Yeah, before like our session is hardware design, na? Like what is the necessary? Like why we need the hardware design? Software is set of program or instruction that run on a computer electronic device. Yeah, perfect. Now tell me, like as we know, the design hardware design. Like why we need the design part? If there is no design, simply you are having the all components you are using by wiring or breadboard like that. What happens? What is the problem? Like why we go for the hardware design? What is the need of that? Anyone? Tell whatever the coming in your mind. No problem.
Sorry for interrupting, Anvesh.
Yes.
Yeah, so actually, he's facing the Wi-Fi issue, and power
Okay.
supply is cut actually. So that's why he's using the phone Wi-Fi. So
Okay.
yeah. So this is the one problem. Yeah.
Okay. Like it will take more time or
It will take some time, 5 to 6 minutes. In meantime, we can talk about the embedded. We can talk about the embedded hardware. What is
Yeah.
the embedded hardware actually? So why these things needed, and the embedded hardware and PCB. So PCB is the part of embedded hardware. Okay, it's a one part. Okay, Yanvis, you can carry on.
Yes. Yeah. Like here, na, like we have discussed about the hardware. Like as you people told, like the physical component, it can feel like touch and see. That is the hardware. Like here, what is the purpose to make a design of the hardware? Anyone?
To solid connection. So when signal comes, तो उसको बोलते हैं ना क्या वो कनेक्शन लूज ना हो जाए.
Okay. या वो भी सही है.
सर आप मेरे को बताइए सर, हम हिंदी में बात कर सकते हैं?
हाँ, बात कर लो. कोई लैंग्वेज फाइन. पर
सर मैं बताता हूँ,
सीखने के लिए कोई लैंग्वेज का प्रॉब्लम नहीं है. ओके, बताइए.
हाँ तो सर आप पूछिए, आपको क्या पूछना है, मैं आपको आंसर देता हूँ.
जी फिर से बोलिए.
सर आप जो क्वेश्चन पूछ रहे थे ना अभी आप क्या पूछ रहे थे, आप बताओ, मैं आपको हिंदी में उसका आंसर देता हूँ. क्योंकि सर मेरे को काफी टाइम हो गया इंजीनियरिंग छोड़े और अब इंग्लिश भी आई गई होगी उसके साथ.
ओके. नहीं, हियर वी आर डिस्कसिंग लाइक हार्डवेयर का मतलब क्या है, हार्डवेयर डिजाइनिंग का क्या जरूरत है, वो डिस्कस कर रहे हैं.
तो मैं जानता हूँ सर, जो हार्डवेयर जैसे फिजिकल कंपोनेंट होते हैं, जैसे कैपेसिटर, रजिस्टर हो गए, ये तो एक्चुअल में जितना भी ये पीसीबी के ऊपर जो सामान लगा रहता है वो एक्चुअल में हार्डवेयर के अंदर आता है. और इसकी जरूरत ये पड़ती है कि जैसे ये माइक्रो कंट्रोलर है, वो तो स्मॉल सिग्नल दे सकता है, लेकिन एक्चुअल में उसको जो प्रोसेसिंग का काम है वो अपने हार्डवेयर नहीं करना है कि कितने एम्पियर के हिसाब से कहाँ पे कौन सा ट्रांजिस्टर लगेगा. ये तो है नहीं कि हम उसको डायरेक्ट ऐसे ही कोई सिग्नल को प्रोसेसिंग करवा लेंगे. तो उसके लिए जो सिग्नल के लिए कोई भी इलेक्ट्रॉनिक्स में कहीं भी अगर कोई चीज लगती है तो हार्डवेयर के बिना पॉसिबल ही नहीं है।
Yes,
और
सही है।
दूसरा सर ये होता है कि दूसरा ये होता है कि हार्डवेयर, अब जैसे पीसीबी डिजाइन करते हैं, पीसीबी डिजाइन तो लगभग बहुत सारे बंदे करते हैं, लेकिन एक प्रोफेशनल डिजाइनर में और नॉर्मल डिजाइनर में ये फर्क होता है कि एक्चुअल में कोई कंपोनेंट हम ऐसे ही नहीं उठा के लगा सकते। अब आईसी की पिन से अगर कोई कंपोनेंट दूर लगा देंगे तो उसमें ऑसिलेशन होने लग जाएगा, उसमें नॉइस आ जाएगी। और कोई ट्रैक हम, जैसे कोई सिग्नल का ट्रैक है, उसको हम ऐसी जगह से गुजार देंगे कि वहां पे मैग्नेटिक फील्ड चेंज होती है, तो उसके अंदर भी वो नॉइस वहीं से घुस जाएगी। तो एक्चुअल में पीसीबी डिजाइन और ये इसका हार्डवेयर है ना, इसको एक्चुअल में कहाँ पे प्लेस करना है, वो हार्डवेयर में आप जैसे आप सिखाओगे ना, तो वो जानना हमारे लिए जरूरी है कि कौन सा ट्रैक है। अगर ये सिग्नल का ट्रैक है तो इसको कहाँ से नहीं गुजरना चाहिए।
Correct,
Yeah,
Ashok. Correct.
perfect, Ashok. Mukul, maybe come back. Mukul, are you there?
Now we can. Sorry
Yeah,
for
Mukul. Fine.
Now, correct. The embedded system is a combination of hardware and software. Unlike a computer, which perform multiple functions, but जो embedded है वो is it is designed for a dedicated purpose. आपके घरों में example है, for example, like your washing machine, smart watch, microwave oven, Wi-Fi, your Wi-Fi router, smart TV, ATM machine. This is the very examples of embedded systems. Then why we learn embedded hardware design? Every electronic product requires hardware before software can run. Then you have to design hardware. If you have to place a phone, then you have a phone in your hand. So you have something hardware to run a software or to do something. So then without hardware, you have no IoT devices, no medical equipment, no industrial controllers, no consumer electronics. So basically, industry is hiring hardware engineers in automobile sectors, medical sectors, industrial automation sectors, consumer electronics, for aerospace, for railways. If you learn embedded hardware or software designing or PCB designing, so what is your career opportunities? What are the jobs available in the market? What type of jobs you can do? Basically, first of all, embedded hardware engineer, PCB design engineer, hardware validation engineer, product development engineer, IoT hardware engineer, and R&D engineer. What is the skill requirement for these jobs? You have to know about the electronics fundamentals. You have the better understanding of circuit designing, PCB designing. You know the hardware debugging, and you have the basic knowledge of communication protocols. What are the communication protocols? And you know the concept of, or you know the basics of power electronics. Then we can understand the hardware development process. What are the steps? What will be the steps for the hardware development process? Every product follow the same process. First of all, we have the requirements. What we have to develop? What is the end product? First of all, we need the requirement. Then after requirement, we have to select the component. We finalize the component. After that component selection, we make the schematic. If we design a product, if we have to design a product, like we have to design a watch, a smart watch, then we have to finalize the requirement. Display size, and the charger output, battery size. First of all, we have to finalize the requirement. After that, we finalize the requirement. We have to select the component, what we have to use, what type of component, what is the size of components we have to use, like resistor, capacitor, displays, battery. Then after the finalization of components, we have to make the design, a schematic design. Then we have to use a MCU, Bluetooth module, because in smartphones we have Bluetooth. We can use a Wi-Fi module also. Then we have to make the schematic. After that, we finalize the schematic. We have to design the PCB layout. Our PCB is in circle. It is in rectangular form. So we have to design. We have to decide according to our requirements. After that, we have to fabricate our PCB and assemble. We have to fabricate our PCB, and then we got the assembled PCB, which we all the components mounted on the PCB. After that, we do the test, what we designed. Then after that, the testing is completed, then we can go for the production. Example, you can see the watch, smart watch, the GPS tracker.
Mukul, you are in mute.
Basically, what is the agenda of this course? We will cover the passive, what is the passive components, why we use the components, passive components, and what is the semiconductor, what is the power supply, and we also understand how to make the power supply. If we need a circuit 12 volt or 230 volt to 12 volt or 12 volt to 3.3 volt, because our microcontrollers work on 3.3 volt, 5 volt, and as well as 1.8 volt. But we have 230 volt AC which is supplied in our houses, and we have 12 volt DC which comes from the UPS battery. So how we make the power supply for our electronics board as well as the power board. So we can design how we can design the power supply. We cover in this course. Then what is the basic of microcontrollers and why we use microcontrollers? How we can select a particular microcontroller for according to our requirement. Then what is the how many peripherals of the controller? Then we have to use the memory. So what type of memories we can use for the microcontroller? Interfaces. How many interfaces are there to communicate a microcontroller to the other ICs like CAN, UART, I2C, SPI, then PCB design. After schematic finalization, we can go for the PCB design. After PCB design, assembled PCB, then we have to debug the PCB. Then we will learn fundamentals of components like resistor. What is the fundamental of resistor? Why we use resistors? Then what is the principle of resistor? Basically, resistors oppose current flow and create voltage drop. What is the unit of resistor? As well as application of resistors, where resistor is used. Capacitor. What is capacitor? What is the use of capacitor? Why we use various values? How we calculate the value of in the circuit? Diodes. Why we use diodes? What is the principle of diode? How many types of diodes are there? we will cover in this course. After diodes, BJT, what is the transistor? What type of transistor? How many types of transistor are there? Why we use NPN transistor as well as PNP transistor? Where we use NPN transistor, so we can cover in this course. After BJT, what is the MOSFET? Why we use MOSFET? The difference between the BJTs and MOSFET. How many types of MOSFETs are there? So then we will cover. After this, we will cover switches. What is a switch? How many types of switches are there? How we can connect? How we can use in our application or according to our requirements? What is the relay? How many types of relay are there? Or how we can use the relay and which relay we can use for our application. We will learn about this. LDOs, what is LDOs? LDO, how we can use the LDOs. LDO is basically linear power supply. It is used for the linear power supply. Basically, we have to convert 12 volt to 3.3 volt, or we can 12 to 35, 36 volt to 3 volt, 5 volt. So we can use LDO regulators. Why we use DC-DC converters? What is DC-DC converters? Basically, it is buck converter or boost converter where if we need a 5 volt and we have 12 volt or 36 volt in our circuit. So how we can get the 3.3 volt? Then we can use a DC-DC converter. So we learn about the DC-DC converters, how it works, how to make DC-DC converter, and it is efficient, very efficient to LDOs over LDOs. That's why we use DC-DC converters over LDOs. And what is embedded system architecture? What we need to design an embedded system. So we will learn about the microcontrollers fundamentals. What is microcontrollers? What is the CPU inside the microcontroller? What is flash? What is RAM? And what is the GPIO of microcontrollers? And we can use the timers, ADC. What is ADC in microcontrollers? And the communication protocols like UART, SPI, I2S, I2C. Then how we design the schematic with the communication peripherals. Basically, clock circuit designing, crystal oscillator selection, how we choose the crystal for the microcontroller, how we choose the load capacitor, what is load capacitor, first of all, we will learn about what is crystal oscillator and common startup issues for debugging. After that, reset circuit design, how to reset the PCB or how to reset a device. So we can power on reset, brownout detection, supervisor ICs, and manual reset. And various memory interfaces, flash, various type of memories like flash, EEPROM, SDRAM, NOR, NAND, flash, and SD cards. Where we use flash, where we use EEPROM. So we will learn about this. After that, we will learn digital IO, interrupt. What is digital IO? What is interrupt? What is LED switches and external interfacing? After that, we will learn UART peripherals. What is UART peripherals? How it communicates? How we can design schematic with UART peripherals? What is the principle of UART peripherals? What is a baud rate configuration? What is debug and control application? After that, the next peripheral is SPI peripheral. Basically, what is SPI peripherals? How many pins for SPI peripherals? Basically, we need 4 pins for SPI peripherals. MISO, MOSI, clock, and chip select. Basically, MISO is master in slave out, and MOSI is master out slave in. this is very high speed synchronous communication. What is I2C peripheral, and what is the difference between I2C and SPI peripheral? And I2C have only two lines, one for data and one for clock. Data input output only for one pin and other for clock. And why we need pull-up registers for I2C communication? So we will learn about the I2C peripherals. CAN bus, what is CAN? Uh, it is differential signaling. Why we use CAN, and in which application we can use CAN in automotive, like your bike, or as well as automotive sectors. The communication is uh, held in CAN protocol. Then what is the use of CAN protocol? We will learn about this. USB and Ethernet. What is USB? What is Ethernet? To have aware about this. So how we can use USB from microcontroller? How we can use Ethernet? We can use a PHY. We can how we can use USB host mode, CDC mode. There are two or three modes in USB. Then how we design the USB schematic, how we design the Ethernet from microcontroller to our board, and we will learn about this. What is the ADC, and we will design the analog design. We get the analog values from the sensors, and we place some circuit and give to the microcontroller, and microcontroller read the analog values and print in digital forms. How we can convert? Then will learn in this course. Then what is the PCB guidelines? If our schematic is finalized, then we have placed the text, or we have placed the notes. Then if we place a capacitor near the MCU, then we give the note in our schematic. Then this capacitor will be placed near the microcontrollers and this pin. Then we make the PCB guidelines in our schematic. We provide the notes. What is hardware debugging? If our circuit is completed and we got the PCB, then some error are there. So how we can debug our hardware? So what the devices we have to purchase, or we have to need to debug the hardware: multimeter, oscilloscope, logic analyzer, and JT, AGA, or SWD. We have the various types of devices to debug the hardware. And after make the schematic, we have to validate and bring the checklist, verify power, clock, reset memories, and interfaces. We have to verify all this before the PCB fabrication, before the PCB fabrication.
Yeah. In meantime, I think you guys have some doubt, right? Anyone?
Tomorrow we will learn about the KiCad or Altium software. I will give you the overview of the KiCad and Altium software.
Yeah. And for this session, like, please guys, if you have any doubt, just let us know. And yeah.
सर मैं ये जानना चाह रहा था कि
Yes.
जैसे सर अभी हम लोग ये सर भी जैसे बात कर रहे हैं तो लगभग इंग्लिश में ही बात कर रहे हैं, और मेरे हिसाब से जितने 100% जितने भी लोग जुड़े हुए हैं वो सब हिंदी तो जानते ही होंगे.
Yes, actually we have the Hindi batch also, so I will show to you. So that's why I told you to wait for some time. Okay. So Hindi batch is Samel ma'am will take care. Okay. So that will going to the PCB designing. Okay. On the hardware parts, like if you want, then I think Mukul sir will teach. Okay. In the Hindi batch, if you see the language here, right? Yeah. So this is the separate batch, and this one is the separate batch. Okay.
Okay.
So those guys wants to in means kind of specific ones, then you can choose this one, and those guys means like want to this one, then you can choose this one. Okay, so based on you.
So I can teach in both the languages. I can mix. I can teach in mix. तो जैसे
सर, मेरे
आपको
को
सही
इंग्लिश
रहे,
समझ
अगर
में
आपको कोई नहीं, आपको जैसे ही कोई क्वेश्चन आता है या कुछ भी आया तो आप मेरे को पूछ सकते हो, मैं आपको जवाब दूंगा। और थोड़ा मैं कोशिश करूंगा कि थोड़ा सा मिक्स करके पढ़ाऊं, लाइक ये क्या होता है तो थोड़ा इंग्लिश में बता दिया, फिर आपके लिए थोड़ा सा
मैं आपको ऐसे बता रहा हूँ ना सर, चलो वो तो आपकी चॉइस है, लेकिन जैसे जैसे कोई ये इलेक्ट्रॉनिक्स में बहुत सारे वर्ड है, वो तो है ही, ये सारे इंग्लिश के, वो तो
हाँ, वो सारे तो इंग्लिश में ही है, वो तो आप समझ जाओगे,
वो तो समझ रहे हैं सर। लेकिन अगर आप ये हिंदी में समझाओगे ना, मेरे लिए नहीं है, आप वोटिंग करवा लेना इस पे, आपको वोट उसी के मिलेंगे नहीं, क्योंकि एक्चुअल में समझ में ज्यादा आता है, क्योंकि हम घर में भी मोस्टली हिंदी में बात करते हैं। आज ये फॉरेन होता तो बात अलग थी। चलो
Ashok, sorry for the interrupt. Okay, there is no problem. Okay, Ashok, once you start the course, na, you can join whatever the course you want, English या Hindi. But in the future, if you have any doubt, ना, हम बोल सकते हैं, सबको आता है।
मैं एडवाइस दे रहा था सर, बाकी मैं तो एडवाइस दे रहा था।
Yeah, fine, Ashok. Any other apart from that language, any other doubt related to designing on the course content wise?
नो सर, ये बाकी क्लियर। आपने जो जितना इसके अंदर ये आपने जो चैप्टर दिया है ना, ये बहुत इंपॉर्टेंट है, और अगर इसमें से समझ में आ जाए तो ये आप कह सकते हो कि एक प्रॉपर इंजीनियर बन सकता है बंदा। इसमें बहुत सारे डाउट्स हैं नीचे, जैसे ये सॉफ्टवेयर के बारे में हो गया, एडीसी हो गया, डीसी हो गया, या जो पीसीबी में जो ये जितने भी एमएफ इंटरफेस है, ये चीज होगी, बहुत अच्छी चीजें हैं। अगर ये अच्छे से समझ में आएंगी तो बहुत बढ़िया बात है सर।
Yes, correct, exactly.
Yeah,
at the first time I told you, no, it's a set of means kind of here you will learn all the things. Okay, how to map it, how to get the requirement, how to think about it actually. Okay, so don't worry,
दिस इज कॉल्ड, ये रिवर्स इंजीनियरिंग भी बोल सकते हैं सर, जैसे आप बोल रहे हैं।
yes, exactly, we can say it. Okay, so today I think might be some problem with the Wi-Fi, so I think voice it would be not nice that much. Okay, so tomorrow we'll see
आपकी सही है, आपकी सही सर। जैसे ये मुकल सर है ना, इनकी थोड़ी लाउडर नहीं है, इसमें थोड़ा भारीपन ज्यादा आवाज।
yeah, correct, exactly, I'm talking about yeah, same, and tomorrow we'll do some of the project also. Okay, so and as last I told you, na, so today if you guys have any doubt, like anyone, if you have any point, any doubt, just let us know. And the thing is, we have some student from the South India also, so I think we'll make 2 batches. Okay, so don't worry, one is the separate. Okay, and if you guys wants to the separate PCB, so we have for the separate PCB also, so Samel ma'am will take care. Okay, for that PCB designing will come up with the webinar next weekend. Okay, but for this kind of hardware designing, the course will be started in the next weekend, and tomorrow we have the final webinar. Okay, and yeah, any doubt you guys, yeah, I will tell you about some of the special things. Any doubt, anyone having like anything in your mind, like as sir told, na? So sir, I think added all the points like diode, capacitors, peripherals, everything. If you learn this thing now, then you can get how to build the things. Okay, so this is the very nice course, I guess.
जी सर, मैं पूछना चाह रहा था,
yes.
जैसे ये जो हार्डवेयर का डिजाइन है, इसका जो ड्यूरेशन है 3 मंथ है सर।
Correct, it will be the yeah, let me say it again, once again I am sharing, just a moment. Somebody is sharing some doubt. I think Mukul sir, can you pick that doubt in meantime? Mukul sir?
yes.
Yeah, can you pick that doubt? Somebody is saying what is the difference between them? Yeah, in meantime, guys, here website, in the website our courses will be listed, and you have to go through this link, and if you want to join, then you can join from here, and I will add you on the WhatsApp group. There you will get all the things. Can somebody okay us okay, we'll talk about it. Don't yeah, we not tell like that. Okay, okay, fine. Yeah, I said you the link also, and yeah, and here you can see the list of all the courses. Just go through whatever you need. Just ping me. Yeah, you have to check it out from here only. Okay, so hardware designing and the course content also I added here, and those guys wants us to the separate in that PCB. As you can see, each module will take some time. Like it's here like one module, nah? It will be the sub module. It will come some like some module here, like this one module, this one module. So it will take some time. It may be more than 3 months. Okay, might be. And if you comes with the PCB design, yeah, in that too many parts are there, it will take some time. So this is the hardware designing, and if anybody wants to the separate PCB designing, then here is the PCB designing separate. As you can see, symbol, ERC checklist, what is the footprint, but this all the things will be there in our hardware designing course. So that's why I'm saying this is the set of things. Like here, if you take, then you will get all the things about the PCB hardware. Okay, and somebody is telling about the what is the difference between the PCB and the hardware.
Yes.
Yeah, yeah. Can you pick that out? Yeah.
अंकित पीसीबी और हार्डवेयर में बेसिकली एक फर्क है. पीसीबी पार्ट है हार्डवेयर का. हार्डवेयर में पीसीबी के अलावा बहुत सारी चीजें आती हैं. यू कैन टेल द कैपेसिटर, रेजिस्टर, माइक्रो कंट्रोलर, ये सब. और पीसीबी भी एक पार्ट है. पीसीबी आपकी बेयर पीसीबी हो गई. अगर आप सपोज करो आपने सिर्फ डिजाइन किया, देन उसके पास आपके पास फैब्रिकेट होके आ गई पीसीबी, तो सिर्फ वो एक पार्ट है हार्डवेयर का. वो कंप्लीट हार्डवेयर नहीं है. कंप्लीट हार्डवेयर क्या है आपका? अगर कोई भी आपका डिवाइस है, लाइक आपके पास वॉच है, तो उसके अंदर जितने सारे कंपोनेंट्स लगे हो, दैट इज द हार्डवेयर. तो पीसीबी इज अ पार्ट ऑफ हार्डवेयर, यू कैन सी.
Yes, perfect. As I told you, now PCB is a part of hardware. Okay, so in that hardware, lot many of the component will be there, and PCB like a part. Okay, so it's a one step. Like firstly, we have to get the requirement, then we'll think how to we have to make that, and the last not last in the mid the PCB will come. Okay, and in the if you take the separate PCB course also, in that also we will talk about the basic component. Will not go in that depth actually, so we'll pick on the basic thing. Okay, so today offers I am telling you. So what the kind of yeah, just one moment, let me share the screen again. Yeah.
I will give you overview the LTM or KiCad software tomorrow, but I'll see you some LTM schematic in LTM. I will share my.
Okay. And the course curriculum I will send you over the just ping me on I think WhatsApp. I will send you the course and things. Okay. And tomorrow session will be the day timing, like it will be the 4 to 5. Okay, and tomorrow we'll make some of the project also. Yeah,
my screen is visible.
Yes. Yeah.
This is the platform which we designed the schematic as well as the PCB. This is called LTM, and this software is used in industry. Basically, 2 or 3 software are used in industry. First of all, LTM. LTM is very common for the industry, and second is ORCAD, and third is KiCad. So we will overview the KiCad and as well as the LTM. Then this is the overview of LTM, and this is the schematic. Here it is a small circuit. Basically, it is a symbol of hole of the PCB, and it is a symbol of connector, which is a 4 pins, and this is the symbol of power VCC in. this is the symbol of LED, this is the symbol of resistance, how we can connect the VCC and VCC connect to LED and LED connect to resistor, and the other pin is goes to the connector, which we provide the ground as well. Then this is a little or short circuit, small circuit for the three LEDs, and here we make the schematic. Now we have to make the PCB for this schematic. Then this is the PCB for this circuit. Basically, here the three LEDs are there, and three resistors are there, and one connector are there, and two holes are there. This is the 2D, and we come for the 3D. Then this is the 3D image of PCB. This is the back side of the PCB, and we have clipped this PCB. Then there is three LEDs are there, and three resistors are there, and one connector are there. This is the overview of PCB. Here, the overview of this PCB. You can learn tomorrow in brief. This is only the overview.
And Mukul, yes Mukul, can we do the small project tomorrow? Small
What?
project? Okay. Yeah. So it will be the good understand. Yeah. Then the people will know. So why we use this kind of how. Yeah.
I'll teach with an example. I'll teach the schematic and in LTM with an example.
Okay.
I'll learn.
Okay, fantastic.
I will teach.
Yeah.
I will teach.
Okay, fantastic. And
Tomorrow.
And for today, something special I told you, no. So just let me allow you one moment. So the course overall fee, if you wanted to join now, if you see the fee, it's a 3,499. Okay, and if you wanted to get now today, then I am just sending the link, special link. So it will be the not like 3,499. It will be the less only. So I am sending the link. Okay, so it is the final price. It will come 2,499. Okay. So this is the valid for the 10 student. So I think this is the time for you. Just check it out and just let me know once the payment is done. Okay. And in the meantime, anybody having the doubts on hardware design, yeah, PCB, yeah, in the testing, so just let us know. Okay. Just check it out. I send you the link. Okay.
Yeah, guys.
If you have.
Yeah, Mukul. Guys, here I thought some of the new to the PCB design, some already have the experience in the PCB design. Here, the main agenda of this webinar is to interact with the mentor to clarify your doubts, whatever you want to know more than. If you know the person already about the PCB design, if you want to more in the PCB design, whatever you are looking into, please discuss with the mentor to make the clear picture what you want from our side. Okay. That's why the webinar is tomorrow. Anyway, we can start the project and all. In the future also, we will post some interesting things about the hardware design, what is the content we are delivering to. But utilize this session. Please interact with the mentor, like what are the doubt you have, whatever the things you want to know. Someone is new to the PCB design, just ask them like what is PCB design, what exactly thing you have to know. Ask the guidance also, like how to get into the PCB design side. Okay, please make interact with the mentor. Please try to utilize this session. Yeah, guys. Yeah, Mukul, you can carry on.
If you have any single doubt, you can ask me, and you can post on the group also. If you have any single issue or query, you can ask.
And don't bother about the language, okay? Hindi, English या तेलुगु.
कोई भी आपको है कोई डाउट है तो आप मुझसे पूछ लो, कोई दिक्कत नहीं है, और आप मेरे को
मैं पूछ लेता हूँ,
व्हाट्सएप भी कर सकते हो. हाँ बताइए.
सर जैसे आपने बोला अपने पास LTM है, काइकेट है और ये ORCAD है, तो सर जैसे चलो ORCAD है वो तो मैंने कर लिया सर, वो काफी है. उसमें जैसे ऑटो राउटर नहीं है अपना, उसमें मैन्युअली ट्रैक्स बनाने पड़ते हैं.
मैं सभी में वैसे तो मैनुअली करने पड़ते हैं, बट अभी एक दो AI टूल्स आए हैं जो भी आपको ट्रैक बना के खुद से दे देते हैं, ऑटो ट्रैक कर देते हैं, बट आपको बाद में खुद से ही करना पड़ेगा। उसमें आप प्रॉपर्टीज डाल सकते हैं कि आपको स्विफ्ट साइज कितना चाहिए या दो ट्रैक के बीच में कितना डिस्टेंस होना चाहिए, बट फाइनल में आपको ही फाइनलाइज करना पड़ता है, उसको एडिट भी करना पड़ता है आपको ही, क्योंकि EMI का आपने बता दिया उसको। हाँ
हाँ जी हाँ जी हाँ जी हाँ जी समझ गया सर मैं
तो वो आपने बता दिया, बट बाद में आपको खुद ही करना पड़ेगा।
वो समझ गया सर कि अगर कोई ट्रैक कहीं गलती से निकल गया, क्योंकि ऑटो राउटर को थोड़ी ना पता है कि यहाँ पे ये जो भी EMI है जहाँ पे थ्रेड कोड
नहीं आपने अगर राउट नहीं हुआ तो फर्स्ट ऑफ ऑल आपको देखना पड़ेगा कि आपने स्कीमेटिक में उसको लेबल सही दिया नहीं दिया। अगर वो भी सही है, अगर उसने नहीं किया तो बाद में बहुत सारे रूल्स होते हैं, DRC चला के देख सकते हो। तो आप बाद में जब फाइनलाइज करते हो आपको PCB, तो आपके पास बहुत सारे टूल्स होते हैं, आप उसको रन करके देख सकते हैं कि मेरा कोई ट्रैक तो हुआ। इंडस्ट्री में ऐसा नहीं है कि हमने स्कीमेटिक बना दिया कोई वैलिडेट नहीं करेगा, तो हर स्टेप पे वैलिडेशन होता है।
ओके सर एक क्वेश्चन और था, जो हम लोग मैनुअल कंपोनेंट इसके अंदर बनाएंगे उनकी फुटप्रिंट बनाएंगे, जैसे मैंने कोई कैपेसिटर बना लिया अलग मेरी वैल्यू का, तो उसको मैं 3D मॉडल में कन्वर्ट कर सकता हूँ?
3D मॉडल भी आपको बनाना पड़ेगा उसका, तो वो
भी मैनुअली
हाँ ये वाला जो कोर्स है ये हार्डवेयर डिजाइन का कोर्स है, और जो हमारा नेक्स्ट कोर्स स्टार्ट हो रहा है वो PCB डिजाइन का हो रहा है। तो उसमें PCB रिलेटेड आप सब कुछ उसमें आपको जानने को मिलेगा। जो भी आपका कंपोनेंट है, अगर कोई कंपोनेंट है उसका कुछ भी नहीं आपके पास है, तो आपके पास डेटा शीट है, तो उसका आप सिंबल बना सकते हैं फॉर स्कीमेटिक डिजाइन। देन उसके लिए आपको लेआउटिंग अगर करनी है तो उसके लिए आपके पास फुटप्रिंट चाहिए, तो वो भी आपको बनाना पड़ेगा डेटा शीट से देख करके। अगर आपको उसका 3D चाहिए तो डेटा शीट में सारे डायमेंशंस दिए होते हैं, तो आपको वो भी डिजाइन करना पड़ेगा खुद से ही। अगर आपके पास कोई लाइब्रेरी नहीं है तो आप खुद से ही वो 3D भी बनाना चाहिए, तो आप बना सकते हो इजीली। उसमें आप 3D बॉडी बना के, तो उसमें आपके पास डायमेंशंस आपको मिल जाएंगे डेटा शीट से, तो आप इजीली बना सकते हो। आपको बस पता होना चाहिए कैसे बनाते हैं। फुटप्रिंट भी आप खुद ही से बना सकते हैं।
सर चलो ओके। और सर ये ऑप्शन भी हमारे पास है कि हम PCB डिजाइन में कौन सा सॉफ्टवेयर यूज करना है, कैड यूज करना है या LTM यूज करना है?
अगर आपको फिर हाँ वो आप कर सकते हो। आपके इंडस्ट्री में कौन सा यूज हो रहा है तो आपको उसी पे